Okay, yeah, okay, perfect. So in the framework of the refresh projects, we're working on dealing with dust and fines, which is the end product of many of the work that we do throughout the process of end-of-life wind turbine blades recycling. So each of the process, like cutting, shredding, and so on, generates dust and fine, which are composed of course, very small fibers, which are practically very low value. So our goal was to turn them into something of value, of course, which could be energy. In our case, we decided to go through high temperature pyrolysis to obtain syngas as the main product and inerts as a secondary product. In this kind of reactions, usually a variety of product is obtained, like gases, char, liquids, and inorganics. While focusing on high temperature, we make sure that the gases are the main output of the process, of course, and char and inorganics, while we minimize the liquid production, since liquid tend to have a higher degree of chemical complexity. So focusing on gases makes it easier for the end user to actually use as an energy carrier. Of course, after the pyrolysis, the gas dump came out already clean and everything. So we go through syngas purification through our technology of scrubbers that we have developed. And also the char, since we have to work at roughly 800 C, we do have to have some post treatment to obtain clean inorganics inert, which can be either used as a filler or just as a byproduct. Here is a picture of our one module of our industrial scale reactor. And on the right, you can see a comparison between the material they worked on, or which is like this dust and fines, compared to a material we worked on in the past, which is, let's say, more forgiving as it is wood-based. And you can see that we have achieved on both cases we have achieved a higher okay, sorry, 1 second. We have achieved a higher than one okay, I have it. A higher than one conversion efficiency on the energy. Using for the wind turbines, since they have a higher amount of inorganic compounds, mainly the fibers, we get 1.3 energy generated over consumed. While, for example, for another more forgiving, as I said, materials such as this HPL, which is the liquid powder from wood laminates, we can reach up over 2 times the generated. Okay? And this time, the feed rate of the fines is at 7.5 kilograms per hour. But we plan on increasing it with our further revision of the reactor, which can improve the amount of material that we can feed through by limiting the agglomerates that can form inside of the reactor. And next, I will show you a mock-up on how this technology that we developed at Enecolab works. Basically, our idea is to have a modular system that can be tied together. For example, here it is a battery of 40 reactors working all together. And of course, the amount of reactor can be tailored on the amount of feedstock that a particular project will require. So to conclude, a brief summary, we were able to develop this technology through 5 revisions on the industrial scale reactor and 3 revisions on the lab scale reactor, a technology that can effectively convert this waste of the waste basically into usable gas and inert solid. Doing so also minimizing the actual amount of mass that was a waste before. and it works through waste to energy system, and it can be, of course, very well integrated into already existing facilities. Thanks again for your attention, and of course, if you have any question, you can leave it in the comments, and we can discuss them later. Thank you.
Thank you, Carlo.